Hello everybody, and welcome to exercise 1E on page 51 of the workbook. In this question, they're asking us to take the derivative of the function square root of cosine of sine squared of x. That is a pretty complicated function that we're looking at. Okay, so let's maybe start by reminding ourselves that when you take the square root of a function, that's equivalent to just raising that function to the 1/2 power. Okay, and to get started on the problem, let's ask ourselves, what kind of structure are we looking at in this function? Notice that it has the form of one big function raised to the 1/2 power. Okay, so it's natural to start by letting u be that entire inside part of our function, and think of our whole function as being just u to the 1/2. Okay, and in general, when you do the chain rule, it's good to choose your u as large as you can. That makes the derivative easier to take at the next step. Okay, so let's see if we can do it. So with that choice of u, our whole function looks like u to the 1/2. How do you take the derivative of u to the 1/2? Well, that's just a power rule. We're going to get 1/2 u to the negative 1/2, and our u is the entire function cosine of sine squared of x. Okay, so 1/2 u to the negative 1/2, and then the second part of the chain rule says we need to multiply by the derivative of the u. Okay, so there's our first step, and we are done with the first part, the 1/2 cosine of sine squared of x to the negative 1/2. There's no more derivative to be taken there. We're done with that. And we come to the next step, and that is, how do we take the derivative of cosine of sine squared of x? Okay, well, notice that that's also a chain rule situation. This time the u, the inside part, is sine squared of x. Okay, so thinking of that as being our whole function, how do you take the derivative of cosine of u? Okay, the derivative of cosine of u is negative sine of u. So we'll get negative sine of u. And again, the second part of the chain rule is to multiply by the derivative of the u, okay, the sine squared of x. Okay, so we've got another piece of the problem that we're done with, and this minus sign that's sitting here, I'm going to take that and move it to the front, okay, just to make the notation a little bit simpler. So we'll take that minus sign, put it way over at the beginning with the 1/2, minus 1/2 cosine of sine squared of x to the negative 1/2 times sine of sine squared of x. We're done with all of that. No more derivatives to take there. What's left for us to do is to take the derivative of sine squared of x. Okay, well, how do we do that? Well, first of all, remember what we mean when we write sine squared of x. That's just another way of writing sine of x all squared. Okay, and I'm going to, in fact, do that. Okay, just rewrite it in that form because I think that'll make this derivative easier to take. Okay, so the derivative of sine of x squared, notice that that's also a chain rule. This time the u is the sine of x. Okay, and so how do you take the derivative of u squared? Well, you get 2u, where the u is sine of x, and then second step of the chain rule again is to multiply by the derivative of the u. That's going to stick a d dx of sine of x on the end. Okay, so you can see this is a lot of work, but we've broken it down really to just one more derivative to take. The derivative of sine of x is just cosine, and we're done. So let's just rewrite this one more time. Okay, 2 sine of x, and then the derivative of sine of x is cosine of x. And you can look at that and see that there are no more derivatives to be taken. And so this is our final answer. Okay, well, that was kind of a long problem. Now you can count. I think we use the chain rule 3 times in that problem, but it's a great illustration of the power of the chain rule. You can take a really complicated function like this one and to break it down into manageable parts and arrive at a derivative for the whole function.